Welcome to your lesson on the sun. That great, big, amazing thing in the sky that keeps us all warm. The sun is creating energy. That is essentially what it is doing. And we all need energy to live on the earth. Now, the sun is absolutely huge. The sun is actually a star. When you go outside at night and you see stars twinkling in the sky, the sun is exactly the same as a star. Not exactly the same, because stars come in different sizes and they have different names. Some of the sorts of names of stars are blue stars, yellow dwarfs, orange dwarfs, red dwarfs. And then you go into your giants and your supergiants. Blue giants, blue supergiants, red giants and red supergiants. So as far as stars go, it's relatively small in comparison to other stars, but at the same time it is so much bigger than Earth. It is also very, very hot up there. It is 5,800 degrees on the surface of the sun. The core of the sun is a lot hotter. It's very, very hot, believe me. I don't recommend anybody go up close to it. So there's all this energy coming out of the sun. There's all this light coming out of the sun. As soon as the sun emits the light, that light starts traveling towards the earth, and that's how we get daylight. But it doesn't reach us immediately. It takes about 8 minutes. So light is moving super fast, but the fact that it doesn't reach us for 8 minutes means that we are so far away from the sun. The sun is 4.6 billion years old. It has a birth and it has a death. It's pretty old, 4.6 billion years. I don't think any of us will get to that age. And it's coming up to halfway through its life cycle. It's expected to live for about another 5 billion years, which is a very, very, very long time. It's staying alight. It's burning through mostly hydrogen and helium. And there's little atoms combining, and there's a process called fusion which keeps the sun alight. At the moment, it's a yellow dwarf. Once all the hydrogen and helium is burnt up, then it's going to become a red giant. And what that means is not a dwarf anymore, it's a giant. It's going to be a big star. They keep expanding and expanding stars, and then eventually everything runs out and they collapse. When this finally happens in about 5 billion years, then the sun will not be a yellow dwarf anymore. It will be a white dwarf. It's going to be smaller at that point, but it's still going to be very, very heavy. So a white dwarf is classified as a dead star. And another type of dead star is called a black hole. A black hole is a super big star, bigger than the sun, that has collapsed and become a dead star. Now, we move around the sun in space in an elliptical orbit, which means our orbit going around the sun is not quite spherical. It means we go out a little bit sort of oblongish, like an egg. And we are moving very, very fast around the sun, about 460 meters per second. Now, if you think of going out onto the oval and running 100 meters that you do in a carnival, in a running race, if you think of doing about 4 or 5 of those running races in 1 second, that is how fast the entire Earth is moving around the sun. What a lot of people don't necessarily know is that the sun is also revolving through space around what they call the galactic center. The galactic center is at the middle of the Milky Way, which is our star system. Our universe is within the Milky Way, and we are all, including the sun, traveling around the galactic center. The speed of our solar system and our sun traveling through space is 720,000 kilometers per hour, which might not mean a lot to you. It's super fast. In that time, I could fly from Perth to London 50 times, Sydney to New York, or Paris to Cape Town about 55 times. So just remember, as we go in an elliptical orbit around the sun, it also is travelling very, very fast through space. There are two movements going on in effect. We continue to travel around the sun, but the sun continues to travel around the galactic centre. Now, the sun is a very, very special thing because without it, none of us would be here. The sun has always been revered, which means it's being held in a special place by many of the older cultures, the ancients who have lived on Earth. There have been different names for sun gods and goddesses. In ancient Greece, they called the sun gods Apollo and Helios. In Incan times, it was Inti. In Egypt, they called the sun god Ra. And in places like Syria, they had a sun goddess, so a female god. Their sun goddess was called Arina. In Japan, it was Amaterasu. So I hope you have enjoyed learning a little bit about the sun. Next time you're standing under a night sky, you can look up at all the stars and know that our sun is exactly the same as a star. They're just different sizes and ages. And the next time you're out there in daylight looking at the sky, we don't look at the sun because it's too harsh for our eyes. You can remember that the sun is hurtling through space at thousands of kilometres per hour. Signing out.